Let's do another system design today, and we'll see today about Twitter. So for the Twitter, try to understand the functional requirement, and then we'll design this. So first, Twitter, we can send tweet. So that can be one functional requirement. We'll be able to send the tweet. Another can be reply tweet. Another we can have like. So if somebody tweets some of the stuff there, then we can like that. So that's another the service. So one person, if you like that, that goes, some API call there. We also maintain that in a database somewhere, so that one person cannot like multiple times same thing. So that can be another functional requirement. Or can we comment tweet some of the tweet? If you see, we can comment that. There is a user timeline and also home timeline. So user timeline, yeah. So user timeline is if any user, if they land to the home page, they can see all the tweets for that particular user. So that's the user timeline. And if you see the home timeline, so in the home timeline, you can see our own tweet and also the friend's tweet also, who we have we are following that. So these are the basic functional requirement. There can be many and more. So just we can start with this. And in a non-functional requirement, we can think that also. So NFR, non-functional requirement. In a non-functional requirement, first thing we can take availability. So in availability, so when we have the Twitter, we expect it should available 100%. If you tweet something in a one region, another region, people can see that every time. It should not be down. So that's why the availability. So that's another the non-functional requirement. It should be scalable. There's a lot of data there when we tweet there. There are a lot of users. So we need to, and when a lot of tweet comes there in a system, then it should handle all of the tweet, and we'll talk about this scalability. So that's also one of the non-functional requirement. Another is low latency. So low latency in the sense, if you like, for the example, you open the user timeline or home timeline, or you want to see the total like there. So there is an API call in the background, and that should be very fast. So we need to see the result as quick as possible. So there should be very low latency over there. And I can say another one, reliability. So there is a lot of data, so no data delete. So Twitter usually doesn't delete any data. So that's why we need the reliability also. And another one you can take uh, consistency. And these are the non-functional requirement, and in almost all system design we need this thing. So consistency in the sense, in a one region we tweet something like in here in the USA, and someone can India will be able to see that at the same time. So that's can be consistency. If it uh, go deep on the consistency, there can be a strong consistency. So yeah, so in this case, we may not need a strong consistency because it's okay. Like if you tweet something in a USA and maybe it may take 1 second, 2 second to be visible in a India, that's fine. So okay, so that's the non-functional requirement. Let's collect some of the facts, and then after that we'll start designing uh, this Twitter. So so facts can be we can I can say there are a lot of users in a Twitter. I think maybe you can just say check like 5 million user. You can find that in a internet. But somewhere I see 300 million users, somewhere 500 million users. Yeah, but just consider there are millions of users in the Twitter. And also I realized for the millions of user, there are 6,000 or 6,000 that's a read request. So every time, every second, like I can say the first second, every second we get 6,000 read requests. So read requests either, someone wants to see the like there, or someone wants to see the user user timeline or home timeline. So those kind of, when we want to see that, we need the data. So we need to fetch that data from somewhere, right? So that's a read request. So read request is 6,000K read request. So that's the fact. There can be, so 6,000 read requests. Yeah, let me correct that. It's not just 6,000. I can just say 6,000 is, it's a write request here, but that's the number, just I found from the internet. But when you say the read request, you can say, 600,000, read requests per second, because that's I realized if there are millions of users, and then at least we can expect this 600,000 read requests per second. Every second we get 6,000. So that is, if you analyze this, one of the fact we realize, this is very read heavy request here in a Twitter. And the write is 6,000, but that's also a big number, 6,000 read requests. So that's a fact. Based on that, we can get some idea, like if it is 600,000, or not 6,000, 6,000 write requests, then if you want to calculate, how many or how big the database we need. So maybe you can just say, okay, 6,000 uh, read request per second. So in a per second we'll get, and I think it's the 140 or 145 bytes or kilobyte of 140 or 45 characters. That's in Twitter that's allowed. So let's say 140 characters. That's byte into 60 in a minute, in a 60 in an hour, and in a 24 like per 1 day. And you can say the 365. We can calculate that, but I just guess, maybe like 200 equal to, yes, equal to approximately it's a 200 petabyte data like per year. So that's a big amount of data. Every year we get this kind of data. So this is the fact, this is the requirement, and this is a non-functional requirement. And by considering all these things, let's try to design the Twitter. Okay, so here I can say, there is a one end, there is a user, and user wants to write something, that is tweet, wants to like something, so that's also right. Or the read way want to see, some total count of like, or user want to see the user timeline or home timeline, or users, all, yeah, so all the comments over there. So from the one end, there is a user. And what it does, so if you user wants something, then it goes to the API server. So there will be API server here, API server. And if you want to write something, then maybe the post call. If you want to read something, get call. There's API server. We can send that request here, API server. And then there will be another end. There will be database. Another end, we can say that's a database. So from the database, we can uh, get the stuff there. So when we tweet, sometime like we see uh, there's a link or media. If you put some media also, if there's a media also in a tweet, so those media, if that's available, that's media. We can store that information here, but the media file itself, can be stored in somewhere in a S3 bucket. So let's find some diagram. Data storage, I can just put these things somewhere. That's I can just say that's a S3 bucket from here. Yeah, so the media, we can store those things there. So that's the basic, that's the basic system design. Like the user can talk to the API server, and from the API server, the data is in a database, and we can get the data, we can write the data. So that's a very basic design. And we got the idea, this way we can start or designing this thing. The complexity is more when we think about, this different kind of service. So or let's say first now, let's consider for just one API server, at least for now, one API server. And in a one API server, users, there are, the 500 million users, and there are 6,000 write requests, any write request come here. So from the API server, if you want to write something in a database, all the 6,000 per second, then it's very difficult, to get that request fulfilled in a database side. Because database has some, either you can choose SQL or no SQL based on our data. So in this case, we see the data is very growable in nature. So we need like horizontal scaling here. In that case, we can choose, some database like NoSQL database. You can just say Cassandra. We can take that also. Cassandra is very popular database. So for the Cassandra also, or let's think there is a uh, Cassandra is a good choice, but let's say if you choose, some kind of MySQL. MySQL is also fine here. MySQL. If you choose a MySQL, then handling 6,000 requests per second, it's not an easy thing. Or if you want to get, you know, 600,000 read requests, that's also very difficult. So maybe in this case, for the read request, we can think, okay, maybe you can make some read replica. So there will be multiple read replica, and there can be multiple based on the request. You can decide that, and you can have the multiple read replica. So from there, when we try to read the data, we can put some like there are many go to the database, but there will be read replica, multiple read replica. So, okay, we can think, okay, that read request can be achieved here. What about, 6,000 write requests per second? So, write request for the write request, we need, the multiple write replica also, but there is no such a concept like we said the write replica here. But there is a concept in database, either in NoSQL or SQL, both there is a concept called the sharding. So if when you say the sharding, in a sharding there will be the uh, multiple this database instance there running, and that's you can just say that just this database runs in one machine, this database run in another machine, and this when you send the request can go to any of this system. So there can be multiple uh, this database, and that's concept is called the sharding. So let's make some note here. Sharding. So using the sharding, if you use the sharding, then if there are 6,000 write requests, that's also easily that can be achievable, because we can have like multiple uh, database, multiple, yeah, this replica that runs in a different system itself. So that's also called distributed processing. Okay, so we can achieve this thing, or we can have, the Cassandra here, and in the Cassandra itself, we have, all this concept of, the uh, multiple this node over there. So there won't be any problem with this kind of the request there. So we can think about the sharding, we can think about uh, Cassandra. So that's good. Another thing is, the API server. This API server it's handling, the all kind of requests. So you can also think of having, the different server for the different purposes. Like let's say that's the API server. Okay, that's fine. We name this. Okay, this is one server for this read read service. You can just say read read services. There can be another one. We can say the timeline service. So like this, we can have the different service here. We can say a search service. So there can be different module for this, or different. We can design also as a separate instance, like the microservice also. We can think in that. But in all the cases, if all the requests come here, you know, for for all the requests, we need a load balancer here. So just in the middle, just I'm going to put one more box, and I will just say this is the load balancer. And user, all the request of the user that goes to uh, load balancer. And from here to, yeah, so all the requests through the load balancer will that goes to the different tweet services or timeline services or different services. It goes there. So that's the one thing. And also, if you see here, In a timeline services, we want to see some data, and that's data we want that response, very fast. So if you send the request and want to get the data from database, even though there is a sharding concept also, and then if you want to get that data in a real time, it will be slow, a little bit slow if you do not use the caching technique over there. So maybe here in a timeline service, you can put some caching technique like redis. So let me bring one more box here. I can put here, and that's I can say that's a redis. So what happen when we tweet the data? So the tweeting data, it goes to the database also, but it also write to the redis also. And then and when we use the timeline and we want to get the data from database, first we'll check the data is in redis or not. And if it is a redis, then we can get the data from the redis. And if it's not in redis, then only we go to the database. And in that way, uh, we'll get response very fast because redis in memory database. So we'll use the so from there that's definitely that's faster than this database. For the search service, of course we want to get the data when we search and we want to get something, and then data we'll get from the database. But the same data, if you also store the same that data copy of the data in a Elasticsearch, then Elasticsearch is very fast. So and we can get the data very quickly. So for the searching purpose, you can use the Elasticsearch database. So that's why just I can put that also where Elasticsearch. Okay, so these are these are the main the concepts here we can put for the tables. We can think about the tables also like if you want to go detail about this, then we can think on that also, but this is the basic design for this Twitter. For the database stuff, we can think about there can be many tables, user table, we can have the tweet table, we can have the like table. So let me put something here like tables. We can have user table, have tweet table, like table, follower table. This kind of tables we can have. We can think about the fields also in user table, user ID, username. You tweet table. If you have the tweet table, then there should be some relationship you can put there in a tweet table, which user, so maybe user ID and the tweet ID. In a like table, we can have uh, the tweet ID and then like ID. Those kind of things we can maintain here. Follower table, we can have the user ID, main user ID, and another field we can have user ID that follow. So we can have those kind of things, and you can go in a detail. Sometimes we need some processing of the data. So there's a lot of data, and Twitter can utilize that data in a real time and process that things like what's happening there, if there is some trend going on there. So in that case, we can think of another service here. So we can have some service like queue service or Kafka. You can put the Kafka, and then uh, another we can just say event processor kind of thing, and processor. So as soon as we tweet the some of the data, that also from here that also goes to the Kafka, And the Kafka, there is another event processor. As soon as the data reach here, that event processor come in action and process that data and does his required job here. So there are uh, many process are here, and we want to in a real time, like we want to see some of uh, the or error rate. You want to see if there is error or so those kind of things we can handle. You can use the new relic also here in the case. So just I want to put some process called new relic. That's the random piece. We can uh, attach this thing new here. So new relic. So from this tweet service, from the tweet service, if some log happens, for the log we can use another service also like the Splunk, but the tweet also supports in the logging. So I mean not a tweet, but New Relic. New Relic also supports the logging. So for the logging also we can use New Relic here, and in New Relic it also you can have the dashboard. You can create the dashboard. You can have the alerting system here we can put here. So this is especially monitoring the system. So in the monitoring system, we can see what's happening in each of the services there. So for that purpose, you can have this also. So that's all, all this basic idea about the Twitter. And, as if you want to deep dive into that, you can take any of this and you can deep dive. Like for the example, there can be something like when we tweet, then in that case we need some ID like tweet ID. So that tweet ID, how will it generate? So there can be some service for the tweet ID also. You can use you can have some another box, and in another box you can have like sequencer, or ID generator. You can put the ID generator, and that keep generating the ID. So that's all for now. Thank you.